Hello, everyone, and welcome back to class. Today, we're going to be talking about probability. And this one, you may want to pace yourself out. It's a little bit bigger subject. And while we're not going to cover everything there is about probability, we are going to get into it pretty good. So if you need to pause and come back to the video, that's perfectly acceptable. Take your time, work through this. There is some things to get your head around. But I know everyone can do it. We're really just using the same methods that we've talked about in the last couple weeks, and we're putting them into a little bit more practical application now. So this will eventually next week be on your shared sheet for your month. But for now, what I would like everyone to do is make your own sheet. You should have your own workbook. Back here in the Students tab, you can see we had in column E, my worksheet, right? So on your worksheet, you should make a tab and label it 2D6. This is a spreadsheet, okay? And then we're gonna get rid of that because I don't need that instruction there. So what we're going to do today is we're going to talk about calculating probability using a spreadsheet, and we're going to talk about it specifically for simple games. Now, as we get started, I want to let you know that this method will work for pretty much anything. For simple probability, for more complex probability, we will need better tools than this. But for simple games, whether that's a video game, board game, dice game, card game, we can use this same method to calculate probability. And what do we mean by calculate probability? Well, let's look at an example. Here's the Royal Game of You should have already played this as one of the example games in class, and you should know the rules by now. If not, be sure and go back and read the rules. They're very simple, less than a page, and it's actually a pretty fun game, holds up pretty well for being 6,000 years old. But you can see in this scenario, after you've played and tracked it, that we have a blue piece here, and we have a red piece 2 spaces away. And what I want to do is I want to figure out, it's blue's turn. What is the probability of blue capturing red? Okay, this is the exact thing I want you to do in your game project. I want you to get out your board and your pieces and set up a scenario like this. This is, one of an infinite number of scenarios that can be set up on this game. But I've set up just this one, and then I want to ask a question about it. And you can ask any question of your game you want. It doesn't matter what the question is or what the setup is. That's not what's important for this. What is important is, given your setup, let's calculate an exact probability, okay? All right, so how do we do that? Let's go all the way back, and we're gonna go to the most basic form, the most simple form of probability there is. And I'm going to say that's 1D2. So when we notate probability, basic probability and specific, when it comes to dice or other multi-sided tools, mostly dice, but also coins, right? We notate them by the number of dice we're rolling, and then the D stands for dice, and then 2. So this is 1D2, or 1 two-sided die. You may know that also as a coin, right? And when we do this, now we can start doing some calculations based on what are the events that can happen. Okay, so in a two-sided coin, we're going to say this coin has a 0 and has a 1. Instead of heads or tails, we're doing 0 or 1, right? Same thing. So actually, let's call this the count. We're going to do the count of that event in that chance. So when we have a 1D2, which is a coin, we flip a coin. If it's a 0 on one side and a 1 on the other, how many zeros are on that coin? I know this seems really simple or maybe oversimplistic. exactly where we want to be right now. We're going to build up to the more sophisticated stuff. So if it sounds like, why are you even asking that? That seems too simple. It's just because we're establishing a baseline. So if it's really obvious, that's good. So how many zeros are on a coin with a 0 and a 1? Well, there's 1. How many ones? There's also 1. Okay. The next thing I want to do is get a total. So I'm going to type in total, and then I'm going to use the function sum, which, we don't really technically need to do because this is so simple. But again, we're preparing for something more sophisticated later on. So we get a total of 2. There are 2 possible options on this coin, heads or tails, 0 or 1. Okay. And then finally, we're going to label the chance. Okay, and the chance is, and this is where we're just starting to dip our toe into something a little bit more sophisticated. The chance equals the count divided by the total. Okay, 0.5, we'll put a percent. However, if I drag this down, if I copy and paste this down, form fill it, any of those 3, it won't work. Let's do it. It's a problem. Because look what happened. It updated, right? This is a relative reference when it needs to have a mixed reference. Okay, so let's look at our 2 parts. I'm going to zoom in a little bit so you can see. I might have to zoom out later to see some bigger stuff, but I want to zoom in here for now. So we can see D2 divided by D4. D2 is right here, 1 divided by D4, which is 50%, makes sense. If I drag this down though, we can see D3 divided by D5. Now D3 is correct, right? That's count. D5 is blank. It's not our total, so that's a problem. That means we want D2 to update, but not D4. So I'm going to put dollar signs in front of both. Technically, you don't need to. You can put a dollar sign just in front of the 4, and that works. But we don't want this moving in any direction, no matter what. So I'm going to go ahead and put it in front of both, hit enter, and then I'm going to drag this down. All right, there we go. Okay, now what I'm going to do is I'm going to take this sum, and I'm going to drag it over 1. Okay, now why would I do that? Why would I drag that over and add up what I already knew was 100%? Well, that's exactly why I did it. I already knew it was 100%. And while this one's pretty easy, and I think everyone can add 50% plus 50%, later on, as we get more sophisticated examples, you won't be able to add it in your head. There'll be many, many digits of decimals, so small that aren't even visible, so it won't be possible. So what we want to do is we want to put in here a data canary. If you watch the lecture on data organization, data canaries is one of the subjects. And this is a perfect practical example of that. Is we want to do a calculation that we already know the answer to. And the reason we do that is we want to make sure it comes out right. So if this says 100%, I know I'm good. If it does not, then I know something else has gone wrong that I might have otherwise missed. Okay, so now that we have this, I want to do some cleanup here and make it look nice. So I'm going to use my standard label there, right? And then my sub label is my events. Okay, then my counts are static. My chance is all a calculation, and my total, this one is a label, and this one is a calculation. There we go. So using my color code that we talked about in a previous lecture, this is the code I have. So I've got my labels here, and then I've got my totals, and then my count is static. It is what it is, okay? All right, so next up, that's 1D2. What I would like to do next is I want to start working our way up in sophistication. So I want to go to the next level up, which is what happens if we have multiple dice, which you're allowed to have in your project. So let's try 2D2, okay? Now to do 2D2, or to do any two-dimensional probability, you need to have 2 dimensions in our calculation. So notice here, when we did our events, they were lined out and our count in a single column, right? In a line. A line is 1 dimension. If you remember back to basic geometry, a line is 1 dimension, and then a square or a graph is 2 dimensions. Okay, so that's what we need to do, is we need to list out our events here, right, like we had here, but instead of in 1 row, we need to put them in 2 dimensions. Now, it just so happens, coincidentally, that a spreadsheet is by its nature 2-dimensional. It has columns and rows, see, columns and rows. And when we select a bunch of area, we make a 2-dimensional graph, height and width, right? So let's go ahead and put in, there's our die, there's our events, 1 and 2, and then we're going to put in our second die. Oh, sorry, it's 0 and 1, my mistake, 0 and 1, 0 and 1, there we go. Okay, and then to make this clear, I'm going to copy and paste the format using the copy and paste formatter, the little paint roller. Okay, and then to make this clear that this is a contained chart grid, I'm going to highlight the borders, right? Make them dark. And now we need to fill this out. Well, let's do this mentally first. So take a look at this and think of what you would fill out these with. Okay, so let's look at each one of these cells. If this looks familiar, and it looks like, didn't we do something like this in biology where it was parents, genes and stuff? Yep, that's exactly the same thing, but this time it's probability instead of biology. So it's the same method, but slightly different usage. Okay, so if we have a 0 and a 0, we end up with 0. If we have a 1 and a 0, we end up with 1. Same down here, 0, 1, 1, 0, same thing. And over here, we have a 1 and a 1, so we'll end up with a 2. Now what we need to do is write a formula to do this calculation for us. Again, we can do this one in our head. It's simple, but very soon, we'll be doing a much more complicated one. So we're going to start with equals. And then I'm just going to do this real quick. There we go. Got the first one. But if I drag this down and over, it works, but there could be a problem later on because notice this one is not adding this one, it's adding this one. So that's an issue. Okay, so what I needed to do is add always this row and this column. So row 6 should be constant and column B should be constant. All right, now let's look at our formula. So I said row 6, there's row 6, and there's column B. Those should be constant. Well, to make those constant, we're going to put a $sign in, but just in front of that so that our reference can move. Now let's drag this down and over again, okay? And notice B always stays the same, and 6 always stays the same, but the other part moves. This is what's called mixed referencing. Okay. So next up, a fun trick for you too. Remember that vertical bar we used last time? If we put that in and then double click the cell, it'll fit. If you double click an empty cell, it doesn't change the spacing. But if we put in that little bar and double click the cell, it'll shrink down to have a little border. And that leaves us a nice gap there that we can use. Okay, so the next thing I want to do is I want to calculate 2D2. And again, I'm going to do events, count, and chance. So I'm just going to copy and paste that. And we'll clean everything up. There we go, looks good. Notice how it just takes a few extra seconds to clean everything up, but it looks so much better, works so much better. It's really worth the time. Okay, so what are our events? Well, that's the contents of this grid. And we can see there's a 0, there's a 1, and there's a 2. All right. So before there was only 2 options. Now there's 3 options. Okay, next up, big deal here. So let's take some time and look at this and go slow. We need to get a count. So what do I need to do? I want to count the number of zeros. Well, let me look. Here's my grid, and there's the 0. There's one of them. And I'm going to count my ones, going to do it manually. 1, 2. I'm going to count my 2s. There's 1. Okay, so now how do I make the computer do this for me? Well, what am I doing? I'm looking in this very specific range in this table here, and I'm counting if I see the event. Okay, so what function? Count if. Right, and I can just start typing count, and I can look. Count a number of values in a data set. So that just tells me how many total numbers there are. Count A is a number of values. This one is a number of numeric values, right? So this counts how many numbers there are there. Count A counts how many anything is there. And then we got some more. Decount does another variation. We have a bunch of different variations, including blank and unique, all kinds of cool stuff. But, ooh, count unique if, that one looks new, fun. But the one we're looking for is a conditional count across a range. Count if, so it says, oh, nope, count if. There we go, count if. So it says, what is our range? Here's our range, right here. It's a little grid we made, but remember this one does not move ever, so we need to lock all of it because it is a fixed range. And then what is our criteria? Now notice if you have like I do, where this drop down help is covering your text, you can use the up arrow to hide it, and then we can then use our mouse here to select our event. We want to look for O and close parentheses. And then I'm going to say no to the autofill every time. You don't have to go ahead, but I just want to show you manually how to do this just in case, because the autofill doesn't always pop up. It's pretty good. It's a pretty cool tool, but it doesn't always pop up. And so I just want to show you what to do if it does not. But feel free to use it if it's applicable. Okay, so now I've got my functions set up. I can now use the form fill widget to drag that down, and we can see there's 1, 0, there it is, 2 1s, there they are, and 1 2. Very good. All right, next up, we're going to do exactly the same thing. I'm going to get a total. I'm just going to copy and paste my total right there, my label, and then I'm going to write a new equals sum, and see you can see the suggestion here. It gets it. Spreadsheets are pretty amazing that way. But again, if you don't see that, then you open parentheses, and then I'm just going to drag down, right, to create a range. Hit tab. There are four possibilities, which makes sense. 1, 2, 3, 4. All right, now our chance. And we're going to do exactly the same thing we did here. And remember, we divided our count, which is relative, by our total, which is absolute. So if we do equal our count divided by our total and make our total absolute, and then we can hit enter. I'm going to go ahead and format this as a percentage and drag that down. And then I'm going to drag over my sum, and then I'm going to catch up with my formatting. There we go. Oops. I like this just to be formatted as a regular old number, and we'll even reduce the number of digits it shows because it doesn't need it. Okay. There we go. And now we're going to move on So let's have a look at this right before we move on. And what I want to do is I want to look at two charts. So I'm going to select my chance 50-50 for my coin. I'm going to insert chart. There we go. Insert chart. And then we have the world's most boring chart. Okay, I'm going to shrink that and put it right here. And it shows you 50-50. Yeah, that is the world's most boring chart. But now I want to insert another chart. Now this is more interesting. Look at this. It's got a peak, a curve. Some would say a bell curve there in the middle. All right, and I'm going to shrink that down so we can just put it right there. We keep a hold of it, have a look at it as we go, and notice the probability is different. 2 has a greater chance than 1 has a greater chance, a 50% chance, count of 2, than 0 or 2. This is a really important concept in games. So if you had a game where you flip 2 coins, you could predict that players would get a 1 total more often than they did a 0 or 2, roughly 50%, but the part of probability is that it never works out perfectly even. There's variance in it, but you can predict that roughly, on average, 50% of the time that the person would get a 1, and 25% of the time they'd get a 0, and 25% of the time they'd get a 2. Okay, so this is a different distribution than a single coin. And if we had a single coin or a single die, right, a 3-sided die that's a 0, 1, 2, it would be an even distribution of 33% or 1/3 for each option, right? So this is different. Okay, so let's move on up. In our game project, we use 6-sided die. Okay, so we want to do that now. We're going to do 1d6. And actually what I'm going to do is I'm not even going to type in the 1d6. I'm going to copy and paste my headers, my labels there, and then just change the d2 to d6, okay? Because we're going to be doing the same thing and then a little bit more. Again, every step we take, we're moving up one more notch, okay? So make sure you have that copied and pasted. The next thing we need to do is we need to put in our events. So what are the events that can happen on a 6-sided die? You can roll a 1, 2, 3, 4, 5, or 6. Okay, and how many of them are there? How many 1s? 1. How many 2s? All of them, right? So then let's do a total, and we'll again do a sum. This should hopefully start to feel a little repetitive. That's good. Okay, and then our chance again equals our count divided by the total. And you can see 16.16. And I am again going to lock the reference to the total because the total doesn't move. And I'm going to change my format to percentage and then drag down. And then I'm going to drag over. And again, just checking to make sure, got 100% total. Feels good. All right, so update the formatting here. And notice I'm trying to keep consistent. This just makes it easier to read, and I hope everyone else can spot that too. Just at a glance, I need to quit doing that. There we go. At a glance, you can just look at the sheet and go, okay, I see this bold, white on black. That's my labels, and that's important stuff. And then the green, those are my calculations. So, it should be pretty easy to spot what is what when we use a consistent color code. Okay, but let's take 1d6 a little bit further. In many people's projects and in many games in general, you're not required to roll a specific number. Let's take the example of a game where you need to roll a 5 or higher, right? I would hope everyone has played some kind of game like that, and they say, roll a 6-sided die and roll a 5 or higher. Well, what does that mean? It's pretty intuitive to us as people. That means roll a 5 or a 6. Well, what's the probability of doing that? What's the probability of rolling a number or higher? Okay, so that's what we're going to put in here in P, and then in Q, we're going to put in or lower. Okay, so how do we find the probability of rolling something or higher? Well, again, let's break this down and start simple and build our way up to complex, because we will. Now notice there will not be a total for these. Because the math just doesn't work out that way. 5 or higher plus 4 or higher, it's not really relevant to what we're asking. So what we want to know is, what is the chance to start of rolling a 6 or higher? Okay, this is kind of a trick question because there's nothing higher than a 6, so we can discount the or higher part. The chance of rolling a 6 or higher is the exact same chance of rolling a 6. Okay, and that means we can just simply say equals, what is the chance of rolling a 6? All right, okay, easy. Now the next one, what's the chance of rolling a 5 or higher? Well, it's the chance of rolling a 5 plus the chance of everything higher. And this is our calculation of everything higher right here in P7. So in P6 here, we want to say our chance of rolling a 5, which is right there in O6, plus our chance of everything higher, which is just a 6, right? Some of the confusion that people have in doing this, this particular exercise is that the way computers talk is very, very literal and not intuitive. The way humans talk is intuitive. So if I were to say to you, what's your chance of rolling a 6 or higher on a 6-sided die? You would say that's kind of a poorly formed English sentence because it's redundant. 6 or higher just means 6. So don't say that. Just say, what's your chance of rolling a 6? But when we talk to computers, they don't intuit anything. So we have to leave in that stuff that seems kind of weird to us. And this is another one of those cases. So when we say, what is your chance of rolling 5 or higher, it's your chance of rolling 5 plus your chance of rolling anything higher, which is only 6. So it's your chance of rolling 5 or 6. Okay, so there it is. There's the formula. And it says 33.3% or 1/3. Does this make sense? Well, 5 and 6 are 2 out of 6. 2 out of 6 is the same as 1 out of 3. That's 1/3. Okay. So now if we have this written correctly, we should be able to drag it up. And there we go. We can see the chance of rolling a 4 or higher is 50%. That makes sense. Half of the numbers on a die are more than 4. They're 4, 5, or 6. Half of the numbers are smaller. All right, same with 3 or better is 66%, and we go up to 83%, and then we have 100. All right, so you have 100% chance of rolling a 1 or higher. Again, seems like a trick question because it just seems like a riddle you would get, right? You know, what's your chance of rolling a 1 or better? It's everything, 100%, right? Okay, so now let's do lower, because sometimes, you know, that it's the opposite. It's the same calculation, but it's the opposite. So what's the same of 1 or lower? It's the same chance as 1, right? So I'm going to look again at my chance column. That's column O. And then again, I'm going to add the chance of rolling a 2, again from column O, not from P. P is independent, has nothing to do with this one, plus what's above. Okay, and again, feel free to stop this video, back up a little bit, slow it down, watch in half speed if you need to. I'm going pretty fast. In a live class, this is usually, we're about 45 minutes in already, so I'm going pretty fast. Okay, so there we have all of our events for 1d6. Now, you probably have guessed where we're going next. 2d6. All right, this is the big one. We've done 1d6, we've done 1d2, we've done 2d2. We have now done all the component parts needed. And what I would challenge you to do at this point is, if you can, pause the video and work ahead. And then just watch the video to make sure that you did it right. But try and do this one on your own. If you look back at everything we've done, you've already learned all the necessary pieces to solve this puzzle. All right, so you've learned all the techniques, you have everything. There's nothing more you need to solve this puzzle and do this calculation. So please pause here and then come back. Okay, did you get it? Well, let's find out. All right, so we need to put in our variations. Okay, we got 1 through 6. We got 1 through 6. I'm going to color code this real quick to make sure I understand what's going on. I'm going to form my grid by putting in some borders, and then I'm going to write my formula. And the way I like to write these formulas is the first one, I just put it in real sloppy using the arrow keys. So this formula isn't right, and you know why it's not right if we look at it. It's because it's all relative. Remember, it needs to be mixed, okay? So, but I like to just put it in first. Get it typed out, make sure I get a result, and now I'm going to adjust the relative absolute. Okay, so column L is where my numbers are, my events are, and then row 10 is where my events are, okay? So I'm looking for L, there's L. I'm gonna lock it, and then there's the 10, all right? And I'm gonna lock that. I'm gonna drag that down, there we go. And then I'm gonna drag that over, and boom, we are done. Yay. Okay, so let's have a look at this before we move on. So we can see it goes from 2 to 12. That makes sense. And if you roll 2d6, and you know, it's a really good idea while you're doing this, go grab your 2 6-sided die and just leave them out in front of you. You may be kind of mind blown about some of the things that you're learning about 6-sided die, and you're like, no, really? Can it really be like that? Yeah, it's actually a good idea to go ahead and have those dice with you, and you can pick them up and roll them around and look at them and see how this is working. Okay, so here we go. We have all these numbers. I got a single 2 and a single 12, and then we have a 3 and a 3 and 11 and 11. Now, what I would like to do right now is I would like to graphically view this, and this is optional, but recommended. I want to look at this in a way that illustrates some important information about the numbers on here. So I'm going to go to Format, and I'm going to go down to Conditional Formatting. This is a really awesome visualization tool. And notice it starts like we made a guess what kind of format you want. No, that's not what we want. What I want to do is go over to Color Scale. And now look what it did. Again, it guessed small to big, right? Small is dark, big is light. That's okay, but what I want to do is I want to distinguish the most and the least. So I'm going to leave the min value at green, and then the midpoint, I'm going to make it a percent, 50%, halfway there, make it white. And then the max value, I want to make it bright red. Okay, so we can see how this transitions. I'm going to go ahead and say done, and then close that window. You can see how this transitions from the one of the littlest, more, all the way more, the most 7s, and then we start counting back down. We have fewer 8s, fewer 9s, fewer 10s, all the way down to 112. Okay, so notice that this is just an expansion of our 2D2, right? It's the same pattern, it's just a larger expansion, okay? So the next thing we need to do is combine everything we've done and do one final table. So again, I'm going to put in I'm actually, just going to copy again from here. 26, we're going to do exactly the same things. Okay, and I'm going to change this to 2d6. Okay, what are our events? One of the big mistakes I see common here is people start with 1. Technically, it won't hurt anything, but there is not a 1 on this table, right? So you can leave it out. You can put it in 0 if you want. You put it in 99, right? And what will it return? Again, this is one of those computer things. If you put in 1, it'll say the count is 0, your chance is 0, and it won't affect anything. So no big deal. Technically correct, not broken, just unnecessary. So we're going to start with 2. And you could form fill this as well, but it's so short. There we go. And next up, we need to do a count. Now remember back where we've already done this. We did this over here, right? Count if from our 2d2 event. So we're going to want to do the exact same thing. Equals count if. And what range? Our table here. Now remember, we're going to have to lock that because that table doesn't move. And then our criteria is our event. Okay, so let's just check. Yep, looking for 2, found one of them. Now, before I copy this down, I need to lock it. So lock the column, lock the row, lock the column, lock the row. And then this needs to be relative because we do want this to move. Right? As I drag this down, I want it to move. So go ahead and double click that down. And now you can see the count of 2 is 1. The number of 3s are 2, number of 4s, 3, etc., all the way up. And now we need to go ahead and get a total. Okay, so a sum. There are 36. Okay, and if we take a 6-sided die times a 6-sided die, or 6 times 6, it ends up at 36. So we are squaring or multiplying to the power of 2 our die, right? And that goes for anything. If we did 2d10, well, the total would be 100, right? If we did 2d8, the total would be 64, et cetera, et cetera. Any number squared, that's the total count. Okay, so now what is the chance of rolling a 1? It's exactly the same thing that we've done before. It is the count divided by the total. And again, we're going to lock that total because the total doesn't move. And if you drag this down and it says divided by 0, you did not lock the total. So there we go, 2.78%. I'm going to drag that down. Now see, this one is the one where we definitely want that canary to check. Because like I said earlier, these are big numbers. They have long decimal places, and adding those up in your head, no way. So to make sure you did it right, go ahead and put in that canary. Okay, let's add some formatting to make it look nice. Again, the wrong format, there we go. Okay, there we have it. And then the next step I want to do is do the same or higher or lower, because we can do the same thing, roll 2d6, what's your chance of getting a 10 or higher? Okay, so let's have a look and do, again, the highest one first. What's your chance of getting 12 or higher? It's the same. What's your chance of getting an 11 or higher? It's your chance of getting an 11, which is 5.56. I'm going to actually go ahead and color code these as well, just to make sure they stand out. That's our totals. So we're going to say 5.56 plus our running total, which is 2.78. Okay. And then we drag up. And if we did it right, the top should be 100%. Same with or lower. And we can drag that down. Okay, we have now done all the calculations we need to, but I want to do a couple more things for visualization. So first, let's do a chart of our 1d6. All right, and remember to do that, we'll use the chance. So we'll select the chance of 1d6 of all those 16s, hit insert, chart. Okay, and we get another very, very boring chart. I'm gonna just kind of squish that in there because it's not real important. And then I want to do the chance of 2d6. Now this one's much more interesting. Chart, there we go. Now look at that guy. I'm going to leave this one a little bit larger. There we go. So look at that guy. Now this is an interesting chart. This is what's called bell curve probability. And notice it really looks just like a sophisticated, larger version, which it is, of our 2D2. 2D2, 2D6, same pattern, same like pyramid, cone, or bell curve, as it's officially called, where you have more in the middle and less on the ends. Okay? All right, so what do we do with this? We have all these cool charts. We have all this probability worked out. What do we do with it? If you remember at the beginning of lecture, let's roll back around. What was our question? It's blue's turn. What is the probability of blue capturing red? Okay, we now have the tools to figure this out. So let's look. Blue needs to get a 2, right? Blue needs to roll a 2, 1, 2 spaces. So if we look at our dice table here, in the royal game of it says if we roll a 6, 7, or 8, you get to move 2 spaces, right? If you roll a 2, you get 0, 3, 4, 5, 1 space, 9, 10, 11, 3, 12, you get 4. Okay, so 6, 7, or 8, you get to move 2. So that means when a player is rolling the die, they need to roll a 6, a 7, or an 8. Okay, so let's look at rolling a 6, a 7, or an 8. That's these numbers right here, 6, 7, 8 combined. So I'm going to put down here all right, and this is our example. And I'm going to put in sum, open this up, and then I'm going to add up the probability of 6 plus 7 plus 8. Okay, so if I roll a 6 or a 7 or an 8, I get the roll I need. So there it is, 6, 7, or 8, 44.4%. So kind of interesting to know, especially when we look at this. Did anyone else predict that you'd have almost a 50-50 chance of capturing in this turn? It doesn't seem like it with all the numbers possible, 0, 1, 2, 3, 4. That's a lot of numbers possible. It doesn't seem like 50% of the time you would be capturing, right? Or nearly, just under 50% of the time. 44.4, it's just under 50%. So while it may seem like you don't have the best chances of capturing, turns out you actually have a very good chance of capturing, but the odds are not in your favor. So if someone were to bet you, will I capture this time? That wouldn't be a very good bet. You wouldn't want to take that as an even bet. Okay, let's look at a few other things. That's an old example. Let's look at a few other things while we're here. So let's notice how many 7. 7 is the most common number. How many of them are there? There are 6. What is the chance? 16.67. Does that seem familiar? Like you just saw it over here? Yeah. You're going to see this number a lot when dealing with 6-sided die. And it's not a coincidence. A lot of things are 1 and 6. And out of all the combinations, there are 6 chances to get a 7, which means 7 is the most common. Again, we can use this to our advantage. If you want something to happen frequently when rolling 2d6, you only want it to be on one number, well, 7 is the most common number. If you want it to happen infrequently, you choose 2 or 12. And look just how different they are. Think about this when making your game. If I said, to end the game, you need to roll a 7. Okay, that's going to take a while, 1 in 6 chance. But if I said to end the game, you need to roll a 12, that's going to take a very, very, very long time. There's less than a 3% chance on each die roll, right? So that's very difficult, and it's important. You can also do the same thing with calculating or higher. If I wanted the game to be over real fast, I'd say roll 3 or better, right? And it's almost guaranteed that the game would end next turn. If I wanted to have a fairly good chance, well, I can deal with 58, which is a little more than 50-50, or I could go down to 41, right? You can do a lot of really interesting fine-tune adjustments to the feel of your game, how it plays, and the mentality of your players by tweaking these probability events up or down just a little bit or combining them, okay? Now, one last thing I do want to cover, because some of you may have doubles as an important factor in your game, not all of you, but some of you might. Well, what does that mean? Okay, well, what are the odds of rolling doubles? Again, it's very easy to calculate. Let's just look at our chart here. So 1 and 1, that's a double. I'm going to hold down Control and click. 2 and 2, that's a double. 3 and 3, 4 and 4, 5 and 5, and 6 and 6. Notice what it is. It's a diagonal in the opposite direction of the 7. And to be extra fancy here, I'm going to make those borders bright yellow and really thick, okay? So notice I've changed the borders on the doubles, and we can see our doubles are 2, 4, 6, 8, 10, and 12. Obviously, they're all even numbers, which makes sense. And the smallest and the largest are always doubles. Again, makes sense. You can't get anything less than 1, 1, which is a double, and it's 2. You can't get anything larger than 6 and 6, which is 12 and a double. Okay, so how many doubles are there? We counted 6. So doubles, there are 6. And then we already know how many there are possibilities there are total. So the double percent chance is 6 divided by the total. And if you predicted, yeah, I bet it's going to be that same number that keeps popping up everywhere else. You are correct. 16.67 popped up yet again. All right, this number just keeps showing up. You can see here, your chance of rolling 10 or higher is again 16.67%. Your chance of rolling 4 or lower is again, and you might say, why is this? Is it voodoo? Is it witchcraft? Well, we just have to look at the count, right? And that's really what probability always comes down to, is a very simple count divided by total. So when we look at the count of 4, 3, 2, there's 3, there's 2, and there's 1. Add that together, that's 6. 6 out of 36 is 16.67%. And we can keep doing that and seeing that over and over and over again. And you might ask yourself, well, what would happen if we weren't using 6-sided die? That number would change, and I would challenge everyone, try this with an 8-sided die, with a 10-sided die. Try it with different dice. You can extend these and do exactly the same calculations we did here with variants of dice, and any die will work in a table like that. Now, you might then ask yourself, what happens if we do 3d6? Okay, that's a very different and much more sophisticated calculation that we're not going to get into today. I would, if you're curious about that, I would encourage you to look it up and research further on that subject, because it's all out there. All this, none of this information is proprietary to this class. This is pretty common knowledge stuff in the world of probability. So do explore further and look it up as you're curious. But these are the basics. for what you need for this class in particular, and for doing your project and understanding your project more deeply. As you're doing your tracking, you should note and see how far off is the tracking from this estimated probability. Because notice, if we rolled the dice 36 times, 2d6, if we rolled them 36 times, we would almost certainly not get these counts. That's not how probability works. It is not an even distribution of exact numbers every time. It's chance, right? It's random. So we may get numbers that are way off. We may get a bunch of 12s. It could happen. We may never get a 7. And that's, nothing's wrong or broken with that. That's just how probability works. Okay. All right, that wraps it up for today. I know that was quite a bit, but and we got through it really fast. Do feel free to jump into Discord if you have general questions. Send us a message if you have specific questions. Be sure to send a message from the correct assignment so we know what you're asking us about, and we can get back with you as quickly as possible. Other than that, have a good day, and be sure to watch the rest of the lectures for this class and let us know if you have any questions. Thank you.